In this video, I will highlight the role of CG location by explaining how it changes the maximum longitudinal reaction forces. If the maximum longitudinal reaction forces change, the optimal force distribution curve also changes accordingly. Here we have a contents quiz and the variation of maximum acceleration and the braking reaction forces for CG height, for the ratio of CG height to wheelbase, for longitudinal CG location. And the answer to the quiz, finally we have a conclusion. Here is a quiz for you. CG height vertically moves by the same distance from the given reference height in two ways. Which of followings has a bigger effect in the maximum braking or acceleration force? Number 1, downwards. Number 2, upwards. Did you get the answer? This graph shows the maximum acceleration and braking force for CG height. Let's think about a vehicle with its CG at the center of a wheelbase. Therefore, L sub F is equal to L sub R. In this analysis, CG height is the independent variable with the range between 0.3 to 0.63 meter. This graph was drawn by Excel. In part 2 video, we have already known that the equation of normalized maximum acceleration and braking force. We have this equation for acceleration and we have this equation for braking. Therefore, G unit for acceleration and braking is inversely proportional to the CG height here. When the longitudinal CG location is fixed, these functions here are the same type of rational function with constant numerator, which is equal to half of L sub R for acceleration and minus half of L sub F for braking. In this graph, we know that CG height gives the more effect to the maximum acceleration and braking, the more it gets down to the road surface in this direction. As you can see in the graph, this area, effect of this area is much greater than the effects of this area here. I will explain how I made the graph in the previous slide. We have the data set for a car, which is the same one in the previous slide. We have two equations of maximum normalized forces for acceleration and for braking. Okay, let's get into the explanation. In the first step, put the geometric data of CG location in Excel sheet here. Decide the CG height increment. In this case, delta H is equal to 0.01, and type the equation in the column H here. And type the equation for L sub F divided by H here. Here. And L sub R divided by H here. And type the equation in the column max acceleration and max deceleration for equation A1 and A2 respectively. Draw the curve using Excel with H in x-axis and the maximum acceleration and both of maximum acceleration and maximum deceleration in y-axis. That's all, guys. Isn't it simple? This picture shows the maximum acceleration and the braking force for the ratio of CG height to wheelbase. we have the same data set of previous slide, but x-axis changed from CG height to the ratio of CG height to wheelbase, which is dimensionless value. In this graph, CG height varies from 0.01 to 1.43 meter. Accordingly, the ratio of CG height to wheelbase varies from 0.03 to 0.5. Then we can make this graph. The same equations will be used for drawing, for acceleration, and for braking. In this graph, we know that the ratio of CG height to wheelbase gives the more effect to the maximum acceleration and the braking force, the smaller value it has. When the ratio gets smaller, the quantity of this maximum force is bigger and bigger. You can see the bigger increment in both of acceleration and braking when the ratio of h to L is getting smaller in this direction, as you can see in the picture. The maximum forces goes to plus or minus infinity with CG location on the road surface. Here, the infinity means there is no tilting acceleration and tilting deceleration because the CG location is on the acting line of acceleration force or braking force. I will explain how I made the graph in the previous slide. We have the data set for a car. The ratio of CG height to wheelbase varies from 0.01 to 1.403 meter. The other data and the equations are the same in the previous graph, and the governing equations are the same. We have two equations here as before. Let's get into the explanation. First, put the geometric data of CG location in the Excel sheet. Here. So wheelbase and the CG height, etc. Decide the increment for CG height. In this example, delta H is equal to 0.028, as you can see. And type the increment equation in the column H divided by L here. Then the column of H divided L calculates the ratio of the CG height to wheelbase automatically. And then type the equation in the column here. Maximum acceleration A1 and the maximum deceleration A2 respectively. And then now we can draw the curve using Excel. This picture explains acceleration and the braking force for longitudinal CG location. The acceleration and the braking forces are directly proportional to the longitudinal CG location. At the point A, CG is somewhere on the vertical line, passing through the center of rear axle. Your vehicle cannot accelerate because it will fall over to the rear side. At the point B, here, CG is somewhere on the vertical line, passing through the center of front axle. You cannot brake because it will fall over to the front side. The vertical red line drawn by arbitrarily here means the vehicle cannot increase both maximum acceleration and the braking simultaneously. The sum of those two values is always the same at every vertical line in the graph here. Therefore, if you move the CG to the front side, you can raise the maximum acceleration force, but lose the maximum braking force in the other side. I will explain how I made the graph in the previous slide. We have the data set for a car, which is the same as before. CG height and the wheelbase are the fixed values, but L sub f varies from 2.806 to 0. In accordance with the L sub f, L sub r also varies from 0 to 2.806 meter. The equations are the same in previous graph here. Then let's get into the explanation. In the first step, put the geometric data of CG location in the Excel sheet here, and decide the increment of the ratio of L sub r to wheelbase. In this example, this value is 0.02 here. And then type the equation for the equal increment of the ratio of L sub r to L. In the next step, type the equation in the column max acceleration and the max deceleration by the two equations A1 and A2. And finally, we can draw the curve using Excel. This picture tells everything about the effect of CG location. Let's place the given CG height here, which is the given reference line in this analysis. In this picture, upward distance, this of u here, and the downward distance, this of d, are the same. When it moves upwards as much as this of u, the corresponding variation of forces is F sub u. And when it moves downwards as much as this of d, the corresponding variation of forces is F sub d. As you can see, F sub d is much larger than F sub u. This tendency gets greater as CG height gets lower in this direction, because the slope of graphs gets steeper when the quantity of the ratio of h to L decreases. Therefore, the downward movement of CG height has the greater effect on the maximum forces than the same amount of the upward movement of CG height does. The very important fact is that the lowering CG is only the measure to improve the maximum acceleration and the braking forces simultaneously. That's why I put an emphasis on lowering CG. We have a conclusion here. CG location gives the more effect to the maximum acceleration and the braking force, the more it gets down to the road surface. The ratio of CG location to wheelbase gives the more effect to the maximum acceleration and the braking force, the smaller value it has. The vehicle cannot increase both maximum acceleration and the braking simultaneously by the longitudinal movement of CG location. The sum of those two values is always the same. And finally, lowering CG is only the measure to improve the maximum acceleration and the braking forces simultaneously. That's all, guys. See you next video. Goodbye. You can easily understand this video if you watch my previous video. Recently, I explained the EBD and the optimum longitudinal force distribution, including EBD logic. That is the part 1 video for the optimum longitudinal force distribution. And I explained the optimum acceleration and the braking force distribution curves and their mechanical properties. And also, I explain in detail how to make the graph by using Excel sheet. Next video will be the optimum longitudinal force distribution, part 4. This video will include distribution curves for different longitudinal location of CG, and the front and the rear force shown in one graph. And finally, the practical example with Excel. See you in next video. Goodbye, guys.